Alright, so this is my video 1 for the week 8 video explainers, problem 55. And in this problem, we are dealing with the physics of circular motion and how it relates to the speed of human walking. So in the first part of the problem, we are trying to find an expression for the person's maximum walking speed. And the easiest way going about this is modeling this through a diagram. So before we go into the diagram, we know that the centripetal force can be calculated through taking the mass and multiplying it by the velocity squared over L. And so we know the mass is going to be the m is the mass of the object, velocity is the velocity of the object, and L is going to be the distance from the center of the circular path to the object. So in this case, it is going to be the length of the leg. So in this diagram, we see L, which is going to be effectively the leg, the particle m moving in the positive x direction, and the normal force, and then the theta from the legs, effectively. So we know that in the x direction, when we're trying to calculate the net force, that's going to be equal to mg cosine theta for the force, which we know from earlier is equal to mv squared over L. And just through some simplification, we find that g cosine theta equals v squared over L, and that's just from eliminating the m variable. And once we isolate v, we get that gl cosine theta, the square root of that, is equal to the velocity. And now, since we're trying to find the max velocity, it's important to note that theta is going to equal to 0 when velocity is at its max. So once we get cosine theta of cosine of 0 is 1, so that simplifies to the maximum velocity is going to equal to the square root of gravity times the length. So in part B, we have an individual of 70 kilograms, and they have a leg length of 70 centimeters, which is going to be 0.7 meters. So we're trying to calculate the maximum walking speed in meters per second and miles per hour. So first, for meters per second, that's just going to be plugging in those values for our original equation. So g being 9.8 meters per second squared, and the length 0.7 meters. And that's going to give our answer of the maximum velocity in meters per second being 2.62. And just to do some conversions to get that into miles per hour, that turns out to be 5.86 miles per hour. And in the problem, it says that a normal walking speed is 3 meters per second, so or miles per hour. So we can kind of gauge the maximum velocity. That's like a good ballpark answer. And then just some of the topics that we covered in this is uniform circular motion, just more stuff about orbital motion. And I guess the tricky part about this is just visualizing it, and that just really, you can kind of clear up a lot of issues and problems you might have if you just draw a diagram, because for the most part, the arithmetic is pretty simple. It's just conceptually drawing it out and visualizing is probably the hardest thing. But yeah.